let's take a look at another example of how we can use the shell method to find a volume. Say, for example, we have y equals the square root of x. So if I look at a region here, say from the square root of x from 0 up until, say, 2. We have this region. And I want to rotate that about an axis. In my last video, we looked at the y-axis. Well, how about we instead rotate it about, say, this line over here? That's going to be, say, x equals 4. Let's use the shell method to find this volume. So we rotate this around like that. So we're going to take the integral from a to b of 2 pi times the shell radius times the shell height, and we're going to integrate with respect to x. So that is the integral from a, that's going to be x equals 0, that's the smallest x we see, up to 2, that's the biggest x we see, of 2 pi, I'm going to pull that out, times the shell radius. The shell radius is the distance from some given x value, say this x value right there, to the line that we're rotating. Usually this value is just x, but in this case it's not. Instead, well, this length here is x. So if we take x and add the blue line, if we take the green plus the blue, we're going to get 4. So really, the length of that blue line is going to be 4 minus x. So that's the shell radius. Now we need the shell height. Well, the shell height is just going to be the height at that x value, which is, in this case, the square root of x, dx. So that is the integral we need to take. So we could go ahead and distribute this 4 and take this x distributed as well. And then we would take this integral using the power rule for integrals. But I'm not going to go ahead and do that because I just wanted to show how we can set up this shell method. If you like this video, be sure to like and subscribe to the channel. That way you don't miss out on any more helpful tips.